Okay, let's see. Today we are going to design the base with the integrated kickstand and the Sawtooth hanger and standoffs for the floating logo sign. This will be video 1, and then from then you will have the base that you can save as a master file and just continue to use this base for every design that you do for the different logos. So we've got Fusion 360 open, and we will go ahead and start with the same two things you always start with. We'll go ahead and save it. I've got a floating logo sign location already set up, so I will do base tutorial, save, and I'll go ahead and create a component. Component will be the base. There will be two components. We'll have a base, and then we will have a kickstand. All right. We'll activate the base, start from there. We'll create a new sketch on the top plane. We'll do a center rectangle. I have reassigned my shortcut R to center rectangle because I use that much more frequently. And this, actually, before we create any geometry, let's go ahead and set up some parameters. This is very important that we do, so that if you have an odd size logo that needs to fit on a different size base, you can always adjust this base accordingly. And everything will be parametric. So the kickstand, the dimensions, the offsets, everything will adjust accordingly whenever you adjust the overall dimensions. So we're just going to worry about two for right now, because those are going to be the two that you're going to adjust in the future. Everything else is going to remain the same. We'll do base height. Right now we'll say 200 millimeters. My 3D printer bed size is 256 by 256, and I found that the 200 millimeter size for the base is a really nice standard size. And we'll do base width, 200 millimeters. Okay, so we have those parameters set up. We'll hit OK. Again, this tutorial is presented with the idea that you already have a ground level framework of how Fusion 360 works. So it may go a little fast, but again, this is not a complete beginner's tutorial. You can find many of those on YouTube. So we've got the parameters set up, and again, I will hit R for rectangle, center rectangle in my case, and we will do height and tab over to width and enter. Roll out a bit, and there we go. Now we will extrude, and the base thickness is going to be 15 millimeters. Hit OK, leave that as a new body since it's already on its own component. So that is the front, and that's generally what it's going to look like. Again, I've designed this before, so I'm going to go ahead and add the chamfers on the front. I always recommend that people, you wait to add any kind of chamfers or roundovers until the very end. But since I already have an idea of what this design looks like, I'm just going to go ahead and do it. So we'll hit chamfer. We'll just select this face, and then that will chamfer all 4 edges. And that chamfer is going to be 6 millimeters. Right. So that's good. And we will flip that around to the back. We will add another sketch. Now, what we're going to do is we'll go ahead and add the standoffs. We'll do C for circle. Add a circle, doesn't matter. Then we're going to dimension this circle. And our standoff diameter is going to be 10 millimeters. Okay. Now, we're going to stay in dimensioning. We will dimension these from the edge. And we will say 13 millimeters from the edge. We will do the same from the other edge. 13. Perfect. Right. Now, we'll go ahead and extrude those. Those bumpers are going to out 6 millimeters. They're going to have a negative 10-degree taper. We're just doing one right now because we will just mirror that to the other side. So again, since I created the base using a center rectangle, we can use the origin for any mirroring operations. Always pay attention to, especially when you're using parameters and you're expecting change in the future, keep the change in mind as you're designing. Parameters do make things a lot easier to update things in the future, but it makes things much more complex during the modeling stage because you really have to think about how this is going to be updated in the future. What kind of changes are you going to make that could break those parameters down the line? So again, I always try to create center rectangles because then I can continue to use the origin to do any mirroring, and that generally keeps everything correct down the road whenever we change the size. And you'll see what I mean in just a second. So let's go to mirror. We're going to mirror a feature. That feature is going to be this extrusion, and I will just, I always select it from the timeline. That way I know for sure that I'm getting the exact feature that I want to get. Mirror plane, again, we are going to use the origin. And then we'll use optimized because that's a little bit faster on your processor. And okay. And then we will right click, go up to repeat mirror. And then we'll stay with features. We can do this mirror. And then we can also do the original one. This time the mirror plane. Do that guy and optimized. Okay. There we go. Now, another thing I recommend if you're doing a parametric design is constantly update your parameters throughout your design. This will keep you in check and make sure that you don't get 2 hours into a design and then realize that your design's going to break every time you update a parameter. And then you have to go back and kind of do some detective work to realize where your error is. So again, I have my hotkey as W for parameters because I use it so often. We'll move this guy over there and let's adjust the height. We'll say 150. Okay, that looks good. And then this one, let's just say 100. All right, perfect. So it still maintains that edge distance and spacing from the edges. And again, because we use the center rectangle, we can always use this origin point to do our mirroring. The origin is never going to change. So it's a real safe way to do a design. Okay. I'm going to revert these back to 200. Again, 200 is going to be the largest that I'm ever going to print this, right? I'm not worried about going up to 300. Again, everything should work fine, right? But as long as it works at 200 and below, and there's always going to be, especially with this kind of design, there is going to be a point in which the design breaks. Because let's say you adjust the height from 200 down to 40, right? Obviously, this kickstand is not going to be able to work with such a short sign. So just keep that in mind. You know, again, all of the designs that I've done, if there is a short and fat logo, it's generally going to be 120 millimeters or so just to keep that ratio correct for the logo. So 9 times out of 10, it works. So we're back there, we'll hit OK, and back to the design. So I'm going to add a new sketch to the back face. And let's do a slot, center to center slot. Actually, let's project first. So P for project. This will give us some geometry that we can use. Actually, I'm just going to select this whole thing. It gives us some geometry to use to work off of. Now we go back and we do our slot, center to center. It'll align us with some of the center points, which makes life a lot easier. So we'll just go there to there. And let's just do 10 millimeters. Good. Okay, let's add, we'll go L for line. Then we're going to press X to make that a construction line. We'll go to the midpoint of here, just hover, and it will snap to that triangle, which is the midpoint. We'll just give ourselves a nice center line here. Yeah, we'll select that point there. And we'll hit D for dimension. And then this top area, we will put that at 13, just like the feet. That way it's always maintains that 13 millimeter spacing, just like the feet. In order to center it properly, we are going to take this line, and we want that line to be coincident. We're going to hold down Shift, and we're going to get to the center point of this one. You can see the X and then that midpoint icon show up. We'll click there. Now, this is locked into place, not moving anywhere. These are still blue because we can still extend this. Now, when we set a dimension, again, this is why you always keep yourself in that mindset of parametric design. So we'll hit D for dimension. We'll say that that looks pretty good. I always like to round just because it helps me sleep at night. Do 100 millimeters. That looks great, right? The problem is, hit W. Let's say that we adjust our width. So we're going to adjust our width to 150. Okay, let's go a little bit more. So let's go down to 130. Now you can see it's overlapping our feet. So once we actually extrude and we have geometry here, that geometry is going to collide. So you need to think of all your features as how they're going to interact with the parametric nature of your design. If it doesn't need to, like the diameter of these feet, right? Those do not need to be parameters because I'm always going to be okay with this being 10 millimeters with that negative 10 degree taper. It's never going to change. However, the length of this sawtooth hanger does need to change according to the width of the sign. So we need to make sure that when that design feature exists, that it has corresponding parametric values. So let's get this back to 200. Exit out of here. So now, in order to do that, it's pretty easy. You don't need to assign a parameter to it. We can go base width divided by 2. So now it's still 100 because our base width is 200 divided by 2. But now, whenever we hit W and go into our parameters, let's adjust it back down to 120. There we go. So now it's at 60. Now that geometry adjusts to our parametric values. We can take it all the way down. We can go to 80. See, 80 still works. It still adjusts it, but with such a small sign like that, because our edge distances are not parametric with the standoff feet, it will start to collide. But that's not the fault of this. That's the fault of us not assigning parameters to the edge distance on these. Again, I have never made one, and I never expect to make a sign that's this thin. So I'm gonna roll with it. I think this will work fine. Bring it back to 200, and we'll get out of here. Okay. So now let's go back into, actually we will select offset, then we will select this. Let's turn this off of construction so that we actually have selectable geometry. And then we can do a 2 millimeter distance there. Hit E for extrude, select that path, and then I'm just going to select the end of this. That way it extrudes the exact same distance as the standoff feet. Actually, so that's 6 millimeters. I'm just going to do 5. So it's a little bit less. The standoff feet are there for a reason. That will give them space to do their jobs and actually offset this from the wall. Okay, we'll say okay. Okay, let's go back into this sketch so we can add the retention features for the Sawtooth hanger. We'll do a 2-point rectangle. Really doesn't matter. Go right there. Take this, and we want that to be coincident with, again, holding shift, finding the midpoint right there. Then we will dimension this 3 millimeters. Now, again, remembering what we said about parametric design, we're going to take this dimension and we are going to say this. We just click on that dimension, then it will give us D19, which will always input the dimension that is. So if I adjust the width of the base to be 100, this is going to turn into 50, which means that it's automatically going to put 50 here as this value. So we'll say that divided by, say, 2. That doesn't look long enough. Let's do 1.5. Yeah, 1.5 looks good. All right. We're going to select that rectangle, mirror. We'll mirror this center line. Oh, sorry. There we go. Select there. Select mirror line. And then click that one. Okay. Now we will finish there. Let's turn that sketch back on. E for extrude. We're going to take both of these. We are going to, instead of starting from the profile plane, we are going to start from an object. So we're going to start from the top of this. And then we are going to extrude in, yeah, we'll say 3 millimeters. That looks fine. Okay, let's turn off the sketch. That looks good. It's a little chunky right now, but again, think of the way that this is going to be printed, right? This is going to be printed on the entire intent of this whole design is that all front showing faces have the nice texture of the textured bed on the 3D printer. So this is going to be printed face down just like this. So we want to make sure that any geometry that we have up here is not going to be floating in the air like it is currently. But we're not worried about that right now because we are going to be adding chamfers to make sure that everything is at the 45 degree. So let's see. Let's do some good practice here. I'm not teaching the right thing here, so let's name our sketches. So this is going to be base profile. It's going to be out of there. Standoff feet. And this one is going to be Sawtooth hanger. All right. Now we are going to create another sketch on top of this sawtooth hanger. Again, I have mine set, my settings to where everything doesn't automatically project, because a lot of times it's more annoying to me than it is helpful. So to project, we're going to project this so that we can work off of the geometry. Because again, if we're trying to sketch on something like this, if we don't have it projected, it's not going to pick up any of that geometry. So again, with this one, we are going to go line. We're going to do a construction line. Let's find the midpoint here. And we'll just bring that down just so that we have a defined midpoint. Now we can just take a line. Ooh, let's turn that off of geometry or construction. Like that. And we'll bring that down. Select both of those equal. That way they are the same length. You can apply, say 5. Go. Now, trying to figure out what is underdefined here because it's still blue. It's not black, so it's not fully defined. But I'm not going to worry about it right now. I am going to do a rectangular pattern. Select this and that. Directions go that way, just like that. We're going to go in symmetrical directions. Bring it back to where it's lined up. And do spacing. There we go. So now we can up it. We'll say 5. I think that's enough to, again, chances are anytime you hang this thing, you're just going to hang it on the center one. So this is probably way over engineered anyway. So let's just go with 5 because I'm not going to put in parametric values here. So we'll do 5. And then again, let's test often. So let's bring this width down to, again, the lowest that I think is ever going to happen is going to be like 130. We'll do 130. Design still works. All 5 of those still fit within there. So I'm good with that. Bring this back to 200. Exit out of there. Okay. Now we can do another line with construction. Do the midpoint there. There. Then we can do another mirror. Hold down Control, select all of these. Mirror line there. Okay. And we'll finish the sketch. Now they're fully defined. Now we can take Actually, what we'll do first is we will chamfer, select this edge and this edge. And let's chamfer those just like that. And now you can see what I'm talking about whenever we print. We're going to print from this orientation. So when this is printing, it's at a 45-degree angle, so it will not need any supports and should print just fine. Hit OK. Now we'll hit extrude, select all of our saw teeth cutouts. We'll extrude those down, and we'll just go to that face. Hit cut. Okay. Now, reason it did not extrude all the way through, it may have been my selection. So let's open that one back up. Bring it down a bit more. 4 millimeters. Still did not go all the way. I don't have the right view here. Five millimeters. Oh, I see. Okay. Okay. Well, that should work just fine. It's going to work exactly how we need it to work. Now, let's just come back here before we get started on the kickstand, and we'll just do some cleanup. We'll do some nice to have. So we'll take that, select all these faces. We'll put a slight round over those, and I think that'll be fine. Everything else looks pretty good. Okay, now next step is going to be the integrated kickstand.